In this lesson, we're going to look at solving quadratic inequalities. Now, before we do that, let's kind of remind ourselves about solving a quadratic equation. So remember, when solving a quadratic equation, we used the quadratic formula. And remember, the quadratic formula can be used with all quadratic equations. But for this particular one, though, we can solve this by factoring. So let's go ahead and do this by factoring. And so when we do this, we have x plus 4 times x minus 2 is equal to 0. So once you factored, remember the next thing that you did was you used the zero factor property. And so we set each factor equal to 0. So that's called the zero factor property. And so when you set each factor equal to 0, we got x plus 4 equals 0, x minus 2 equals 0. And so the solutions to this equation are negative 4. And when x minus 2 equals 0, that's when x equals 2. So those are your two solutions. Okay. Now at some point in the semester, we're also going to call these zeros. So these are going to be called zeros as well. So in the zero factor property, you have the word zero. Basically, you're finding for what values of x are these factors equal to 0. So you're finding those zeros in another sense. But what we want to do here, though, is we want to solve a quadratic inequality and not a quadratic equation. So let's look at that first example. So here's number 1. We have x plus 4 times x minus 2 is greater than 0. So I want you to notice those factors right here. So those factors are the same factors that you had here in this quadratic equation, except this time, instead of saying that this product is equal to 0, we have that this product is greater than 0. And so the process of solving a polynomial inequality, in this case it's quadratic, a quadratic inequality or any polynomial inequality, is a little bit more involved than what you did for this. See, when you solve this, you got this and you're done, right? You're done. Those are solutions. But when you solve a quadratic inequality or a polynomial inequality, there's a little bit more work you have to do. All right, so let's talk about that. Okay, so here are the steps. So these are the steps to solving a polynomial inequality. In this case, it's a quadratic. But any polynomial inequality, first thing you want to do is write the inequality in standard form, meaning that you want to make sure that the number 0 is isolated on one side. So if you look at this example, you have 0 on one side. So step number 1's already been done. Okay? Then step number 2 is you want to identify the zeros. So it's kind of like we did here. When we solved this quadratic equation, we set each of those factors equal to 0, and these numbers were called your zeros. So those are your zeros. So zeros are solutions. Okay? And so the same process is here. All right, so listen carefully to this. So you want to identify your zeros. So if the polynomial is not factored, you factor it to find all solutions. So this polynomial is already factored. It's already in factored form. These zeros are sometimes called critical numbers or boundary points. So depending on the textbook, depending on the lesson, sometimes they'll call them zeros. Sometimes they'll call them critical numbers. Sometimes you'll hear the word boundary points. Okay? But let's talk about number 2. Well, how do we find those zeros? All you do to find the zeros, so the next step is to find the zeros. So find the zeros. Or remember, sometimes called critical numbers. Critical numbers. So to find the zeros, you're going to do it just like you did these. You're going to set each factor equal to 0. So to find the zeros, you're going to set each factor equal to 0. So set each factor equal to 0. And you're going to solve the equation. So I have x plus 4 equals 0. And then x minus 2 equals 0. So when I solve each of those linear equations, I get x to be negative 4 and x to be 2. So those are your zeros. So the zeros are negative 4 and 2. Okay? Very simple. So that was step 2. So step 2, identify your zeros. I've identified my zeros. They are -4 and 2. Okay? So now what we're going to do is this. All right, so that's where the rest of this is different. So when we solved this quadratic equation, we were done. You found your solutions, you found your zeros, you are done. With an inequality, you got to go further than this. All right? And so that is steps, or that are steps 3, 4, 5, and 6. All right, so let's talk about 3. Once you find your zeros, you're going to put those zeros on the number line. And you're going to make sure that those zeros are in increasing order. So in other words, put them in numerical order on the number line. Okay? So here's the next step. So we're going to put those zeros on the number line. So you draw your number line just like this. We have -4 and 2. So -4 is smaller than 2. So you put -4 first. And then 2. Okay? All right, so that's the next thing you're going to do. Now I want you to notice that these zeros divided the number line into intervals. So you see this number line right here that goes from -infinity to +infinity? I have 2 zeros. So I have this interval. I'm just going to draw it like this. I have this interval from -infinity to -4. And then I have the second interval from -4 to 2. And then I have the third interval from 2 to infinity. So there are 3 intervals. This interval, this interval, this interval. From -infinity to -4, from -4 to 2, and then from 2 to infinity. Okay? All right, now, so the question is, well, okay, so what do you do with this? All right, so listen carefully to the rest now. So, step 4. Determine the sign of the polynomial in each of those intervals. So that's where most of your work will be. Most of your work will be in step number 4. That's where most of your work will be. So we have to determine the sign of the polynomial in each interval. So in other words, and let me go ahead and kind of use this. So in other words, I'm going to go draw this over. So in other words, if in this case, my zeros are -4 and 2, and there are 3 intervals. There's this interval, this interval, this interval. Okay? So the question is this. In this interval, is this product, okay, is this product positive, negative? That's the question. Is this product positive or negative? Okay? In this interval, is this product positive or negative? That's your question. That's what you have to answer. In this interval, from 2 to infinity, is my product positive or negative? Is this product positive or negative? Okay? All right, now the next thing you're going to ask yourself is this, and this is going to be important as we move along. You see that you have 3 intervals, right? Now remember, -4 and 2, -4 and 2 are the numbers, or the values that makes this product 0. Those are your zeros. So at -4 and 2, this value here is 0. So at -4 I get 0, at 2 I get 0. But in these intervals, it's either going to be a positive number or negative. In this interval, no matter where I am here, it's either going to be positive or negative. In this interval, it's either going to be positive or negative. At those critical numbers, my value is 0, because that's how I found the critical number. I set that equal to 0. So when x is -4, I get 0. When x is 2, I get 0. You can check it. When x is -4, what's -4 plus 4? 0. -4, -2, -6. 0 times -6 is 0, right? So that's 0. Okay, now let's go back and rewrite this or redraw this. Once you get it, once you understand number 1, the rest is easy. It's quick. So we're spending a lot of time discussing this first one. So I'm going to go back and redraw this. So -4, 2. Okay, so remember 3 intervals. 1, 2, 3. -infinity to -4, negative 4 to 2, and then 2 to infinity. Okay, so you may say, now your question is, well, how do you determine if it's positive or negative in this interval? How do you determine if this polynomial here, or this product, is positive or negative in this interval? How do you determine if this product here is positive or negative in this interval? All right, fair question. Very simple. You are going to use what's called a test point. So you're going to choose a test point from each interval to evaluate the polynomial. Now we're going to the next bullet. You're going to set up a table, and you're going to substitute each test point into the polynomial. Okay, so there are a couple of methods here in this little part here. There are a couple ways you could do this. All right, so here's the way that I would do this, and then we're going to do the table form as well. All right, in all of those problems, we're going to do, they're going to be factorable. So when you use a test point, remember, you're going to choose a test point in each interval. And in this case, how many intervals are there? There are 3. 1, 2, 3. You're going to pick a test point, 3 test points. 1 here, 1 here, 1 here. Okay? And what I want you to notice is that this is already factored. Okay? So when you use that test point, just go to the factors. Just go to the factors and determine, is it positive or negative? Now, before we go any further, I want you to remember this. If I say that this product is greater than 0, okay? If I say this product is greater than 0, that means it is positive. Any number greater than 0 is positive. If this is less than 0, then that would mean this product is negative. Any number less than 0 is negative, okay? All right, so keep that also in mind. That's also important to see as well. Okay. So before we go any further, let's pick our test points. So I got to pick a number between negative infinity and negative 4. You can pick any number you want to. You can pick negative 100. You can pick negative 2,000. It does not matter. Most students, though, they pick a number, 1 or 2 numbers to the left, integers, and you can use decimals, by the way. So if you want to say negative 5.2, you can. I don't know why you would, but you can. Almost all students will choose 1 or 2 integers to the left of this 0. So in other words, negative 5, negative 6, negative 7, something like that. So if you want your test point to be negative 7, so negative 7 is my test point. That's my test point. In that interval, then here's what you do. Very simple. Listen carefully. So in your mind, you're saying this. You're saying, all right, I have negative 7. So in place of x, you're going to substitute negative 7. Negative 7 plus 4 times negative 7 minus 2, right? And all you have to do is just ask yourself, is this factor negative or positive? Is this factor negative or positive? You don't have to actually, on your calculator, figure out, well, what's negative 7 plus 4? Negative 7 plus 4 is negative 3. But all you really need to know is this. Is it negative or positive? Well, that is negative, right? It's negative 3, but that doesn't matter. I just need to know, is it negative or positive? Then we go to the next one. A negative and a negative, when you add 2 negatives together, it's still negative, right? Now, in this case, negative 2 and a negative 7 is a negative 9, and a negative 3 times a negative 9 is a positive 27, right? So a negative times a negative is a positive. So this is positive. So no matter what test point I choose between negative infinity and negative 4, this product is positive. So we're going to write the word positive right here. Write the word positive. From negative 4 to 2. And by the way, if you did the same thing with any test point, it does not matter. So for example, if you use a test point negative, let's say 8, is this still going to be positive? Let's see. All right, watch. Negative 8 plus 4 times negative 8 minus 2, right? And then negative 8 plus 4 is negative. It's a negative 4. Negative 8, negative 2 is also negative. It's a negative 10. A negative times a negative is a positive. So you see, it does not matter. It does not matter what test point you use between negative infinity and this 0. All those values, when you substitute, this product will always be positive. All right, very simple. And the more you do, the quicker it becomes. So let's look at the next one. So I need one test point between -4 and 2. Now don't choose -4 and don't choose 2 because you know what those are. If you substitute -4 and 2, that gives you 0, right? I'm going to put 0 here. That gives you 0. Okay, so you got to pick a number between -4 and 2. All right, so for example, you may want to say, well, I'm going to choose -1. Okay, that's fine. What is the easier number to use, though? What do you think is the easiest number to use between -4 and 2, the easiest integer between -4 and 2? Yeah, I would have chosen 0. Choose 0 as your test point. If you can use 0 as your test point, use it. It makes things so much easier for you. So we'll do both of them. I'll show you. All right, now here's what I would do. Now listen carefully. So if you use -1 as your test point or any other integer in here or decimal, doesn't matter, a fraction, it doesn't matter, as long as it's between -4 and 2. Okay, you're going to go back and you're going to substitute those numbers in here and see what kind of numbers these are. So if x is -1, I have -1 plus 4 times -1 minus 2, right? What's -1 plus 4? Well, that's a positive 3. Positive. What's -1 and -2? Well, that's a -3. And what's a positive times a negative? Well, positive times a negative is a negative. So what that means is that any number, any value of x that's between -4 and 2 will make this product negative. That's what that means. So if you want to try 0, watch. I'm going to do it here. Listen carefully. If you use test point 0, watch. 0 plus 4 is 4, right? That's positive. 0 minus 2 is negative. Positive times a negative is a negative. Okay? All right, now one more interval. You got to pick one more test point. So if I pick the test point, let's say any number between 2 and infinity, so let's say 4. We're going to go back, and in place of those values for x, I'm going to substitute 4. Okay? So 4 plus 4 times 4 minus 2. And really all you need to do is determine the product of those signs. 4 plus 4 is 8. That's positive. It's 8 though, right? And then 4 minus 2 is positive. It's really positive 2. And so we get 16, correct? Which is positive. So I want you to think about this, 16. Okay, so 16 is greater than 0, right? So that's a positive number. So remember, this product here, anywhere between 2 to infinity, if I substitute any number, any test point between 2 to infinity, that product better be positive. It better be, in this case, it was 16. If I choose, let's say, 8, if I choose 8, okay, so sorry about that. That was, we're in a hurricane right now, so that was a hurricane warning. Okay, so if I choose 8, here's what I get. I get, I'm going to go ahead and do that here. I get 8 plus 4 times 8 minus 2. And remember, it has to be positive, right? It has to be positive. Okay, so let's look at this. 8 plus 4 is 12. 8 minus 2 is 6. And then you know that a positive 12 times a positive 6 is positive, correct? In this case, 12 times 6, if you use your calculator, 12 times 6 is actually 72. So we know it's positive. All right, now, okay, so a lot of discussion here. A lot of discussion based on this process. Okay, now here's what I found. Listen carefully. Here's what I found. Between negative infinity and -4, no matter what number I choose for x, this product is going to be positive. From -4 to 2, this product is going to be negative. Between 2 to infinity, this product is going to be positive. Okay? All right, now you may say, all right, well, we did all this work, so how do I find the solutions to this inequality? How do I find the solutions? Very simple. This is the most work. Once you get to that point, you're almost done. You are almost done. Okay, so here is step 5. Oh, by the way, so you see where it says set up a table and substitute each test point into the polynomial? Here's another way you could do it. This is the way that I normally do it because now most of the time, I'm just going to say this though, in our case it will be factorable. So if it's factorable, this is the way I do it. I look at the factors. But if it's not factorable, then you're going to have to choose some other method, and that's that table form. So here's the table you could use. So in the table, you would have basically you'd have your test point, okay? And then, so here's your test point. And then the next, and so in this case, you'd say test point is -7, x equal -7. Then you have your other test point is x equal, what was that, -1. Then your other one was test point 4, okay? And then you would determine the value of polynomial. So the value of the polynomial, if x is -7, you would say, you substitute into here. You'd say, let me write it right here. You'd say -7 plus 4 times -7 minus 2. So that's going to equal -3 rather, times a -9, which is a +27. So then you're going to say, so the sign of product, you're going to say positive. Then for x equal -1, do the same thing. You're going to say -1 plus 4 times -1 minus 2. -1 plus 4 is 3. 3 times and -1 minus 2 is a -3. So I get a -9. So that product is negative. And over here, x equal 4, you're going to say 4 plus 4 times 4 minus 2. So that's 8 times 2, which is 16, which is positive. Okay? And notice these right here is the same thing you saw here. Positive, negative, positive. Positive, negative, positive. Okay? All right, now, one other thing you got to be careful. If you do it in table form, you got to be careful. You have to indicate the interval for those. So for this interval, it's positive in the interval -infinity to -4. Okay? It is negative in the interval -4 to 2. And it is positive in the interval, so this one here, so this test point came from the interval 2 to infinity. So in this interval, this is the test point I used. In this interval, this is a test point I used. In this interval, this is a test point I used. Okay? All right. Now, so a lot of discussions here. A lot of discussion. So what I'm going to do now is I'm going to redo number 1 to what you would actually do. Okay, so now, and then, by the way, step 6, I should say this. So identify the intervals which makes the inequality true. That's step 5. So identify the intervals that make the inequality true. So go back to the inequality and ask yourself, this product, I want to be greater than 0. Greater than 0 means I want this to be positive. Okay, that's what that means. Greater than 0 means positive. So then I ask myself, where do I see the word positive? I see the word positive here, and I see the word positive here. So I circled this interval, and I circled this interval. Okay, so that was number 5. I identified the intervals which makes the inequality true. I wanted this inequality to be positive. So the intervals that make that inequality true is this interval and this interval. Not this interval, not this one, because that makes the inequality negative. So now step 6, you write the solution in interval notation. So your solution then, okay, now here's where you also have to be careful. You have to look to see if there's an equal sign or not. So you see there's no equal sign. It's just a strict inequality, right? I'm using the word strict. Strict inequality, meaning there's no equal sign. So strictly greater than 0. So that means positive. Since there's no equal sign, I'm going to use parentheses. Now we're going to do one in a little while where you're going to have equal sign and you're going to see what to do. So your solution are going to be from negative infinity to negative 4, and always go from smallest to largest. Remember how to write an interval. You write an interval from smallest to largest. So when you look at this number line, you go from left to right, left to right. So you're going to go from negative infinity to negative 4, parentheses, union. So in your alta assignments, new assignments, you're going to ask you to use the symbol union. So union, 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 and then the other one is from 2 to infinity, parentheses 2 to infinity. Notice all these are parentheses. Infinity, negative infinity is always parentheses. For those zeros, negative 4 and 2, we have to use parentheses because there's no equal sign here. It's a strict inequality. Whenever there's no equal sign, you're going to use parentheses at those zeros. And that's all you do. That's all you do. All right? So let's redo this. Let's redo this in the way that you would actually go about doing it, where you would show the work. All right? So here's number 1 again, redone. Okay, number 1. We have x plus 4 times x minus 2 is greater than 0. All right. Now, you have a polynomial inequality. In this case, it's quadratic. What I would first do is ask myself, I want this product to be greater than 0, meaning I want this product to be what number? What kind of number? Positive. So that way I know that when I look at this, anything that's positive will be my solution. Okay? All right. So let's go through the steps again. So, step number 1. The inequality is already in standard form. You already have 0 there. And it is already factored, right? So now we can easily identify the zeros. And whenever it's factored, that's easy to identify the zeros. Because in your mind, you're thinking, and remember the other word for 0 is critical number or boundary point. So your critical numbers are going to be negative 4 and positive 2, right? Because you're saying x plus 4 equals 0. You just say each factor equals 0. X plus 4 equals 0, so x equals negative 4. X minus 2 equals 0. X equals 2. So those are your zeros. Once you get your zeros, remember the next step, once you get your zeros, is to put them on a number line and put them in order. So you have negative 4, positive 2. Okay? Okay, now, once you put them on the number line, your next step is to do test. Now that's where remember this part is going to be most of your work. So you have to pick test points now and determine what this product is. So pick a number in this interval, pick a number in this interval, pick a number in this interval. Remember your intervals are negative infinity to negative 4, negative 4 to 2, 2 to infinity. Remember, negative 4 and 2, these numbers here are zeros, are your zeros. That means if you substitute negative 4 into here, you're going to get 0. If you substitute 2 into here, you're going to get 0. That's what that means. And you know it's true because 2 plus 4 is 6, 2 minus 2 is 0, 6 times 2 is 0. That's why those are called zeros. Okay, pick a test point. Let's say we pick the test point negative 8 here. Pick a test point here. So let's say the test point is 0. Pick a test point here. Let's say it's 5. So we're going to use those test points. We're going to substitute it into this product right here, into these factors. And so all you do, the quickest way to do that is ask yourself, if x is negative 8 plus 4 is what kind of number? Negative 8 plus 4 is negative, right? Negative 8 and a negative 2 is negative. A negative times a negative is a positive. All right, is that something I want? Is this interval going to be a solution? The answer is yes. So I'm going to check it off. I'm going to need it. Let's go to the next one, 0. Test point 0. If x is 0, 0 plus 4 is positive. 0 minus 2 is negative. Oops, negative. A positive times a negative is a negative. Is that the interval? Is this interval going to be a solution? No, because I need this product to be what kind of number? Greater than 0 means positive. So I'm not going to use that interval. Let's go to the next one, 5. If x is 5, I get 5 plus 4, which is 9. That's positive. 5 minus 2 is 3. That's positive. A positive times a positive is a positive. That means that in this interval, no matter what test point I use, if you pick 10.7, this product is going to be positive. This product here will be positive. So any number in that interval will make this product positive. So I found my solution. So now you indicate your solutions, and by the way, you gotta always look to see if you have an equal sign here. Since there's no equal sign, these are going to be parentheses. Parentheses. Okay? These are going to be parentheses. That's the word parentheses right here. Okay, so your answer, solution, is negative infinity to negative 4, union 2 to infinity. And always go from smallest to largest. Always go from left to right. So you put this first, you put this next. Okay? And there's your answer. You're done. That's your solution. Now before I go on, I just want to show you this. So at some point in a couple of weeks, you're going to be graphing quadratic equations. And I want to show you that if you look at this the graph of this quadratic equation here, if you look at this, it's actually this right here. Looks like this. Now here's the x-axis. The y-axis, remember the y-axis goes through the origin. So let's say that and it's not scaled very well. So let's say it is right here. Let me go ahead and redraw this. So it's going to be at -1. So let's say this is -1 right here. I didn't draw it very well. Just bear with me. So let's say this is your y-axis right here. So this is what the graph looks like. This is not going to be the vertex, by the way. This low point right here. I didn't draw it very well, but that's not the point. The point is what you see. So going back here, right here, I wanted this product to be positive, right? I want this product to be positive. So notice that when I ask this product to be positive, in terms of the graph, I'm talking about the y values. So these y values, where are the y values positive? Where are the y values positive? That's what you're asking. So the y values are positive above the x-axis. So here, right? And here. So that's where my y values are positive. So notice that from negative infinity to -4, my y values are positive. From 2 to infinity, my y values are positive. Now, I said up to -4. Now at -4 it's actually 0, and then at 2 it's 0. So I should have said from negative infinity up to -4, my y values are positive, and then any number greater than 2, when x is 2, my y values are positive. So notice those are the two intervals right here, from negative infinity to -4. So from negative infinity to -4, my y value is positive here. So the graph is above the x-axis. So whenever the graph is above the x-axis, your y values are positive. When a graph is below the x-axis, your y values are negative. And so the question is, in terms of the graph, where are the y values positive? So from negative infinity to -4, and from 2 to infinity, with parentheses at -4 and 2. Okay, so that's basically what it looks like in terms of a graph. Okay, so we're going to look at some more. I'm going to do some more examples in the next video, but this discussion took quite a bit of time, and that's a pretty good discussion, because you have to understand the process of going through these steps with the discussion here. Okay, so once we got through this discussion, then it was fairly quick to go through those steps using that same example and get the answer quick. So these problems are not that difficult. They're very easy to do. They're very easy to do. You just got to think through the process. What does each of these things mean in terms of this process here? Okay. All right. So I'm going to end this video now. Although we just did one problem, but most of that was through a discussion, and then the problems 2 through 4 I'll do the next video, and it will be a quicker process.